Let's look at finding and using the slopes of lines and writing and graphing equations of lines, specifically having to do with parallel and perpendicular lines. And the essential question reflects that: what are the slopes of parallel and perpendicular lines? Well, let's find the slope of a line that passes through the two given points, -3, 4 and 0, 7. We're going to use the formula for the slope, y2 minus y1 divided by x2 minus x1. We're going to label our points so we can see which is which. Since this -3, 4 is listed first, let's call the -3 x1 and the 4 y1. We'll call 0 our x2 and 7 our y2, and that way we'll see where each value gets substituted into our slope formula. So you can see y2 is 7 minus y1, which is 4, x2 is 0 minus x1, which is -3. Simplifying, we get a slope of 1. Find the slope of the line containing these 2 points. So again, we'll label x1, y1, x2, and y2, and our slope m is going to be our y2 minus our y1 over our x2 minus our x1. We'll end up with a -1 over 12 as our slope. How about this example? x1, y1, x2, y2. You might notice something interesting about this example. Since our y's are the exact same value, when we plug in y2 minus y1 over x2 minus x1, you'll see we'll end up with 0 in our numerator, 0 over -5. 0 in the numerator will result in what final answer for the slope? 0 in the numerator divided by -5 is 0. Well, what kind of a line has a slope of 0? It's a special kind of line, horizontal lines. What about this example? Here, similar to the last one, except that now our x coordinates are the same. See, our x1 and x2 are the same. So slope is y1 minus y2 over x2, y2 minus y1 over x2 minus x1. And this results in 0 in the denominator. And what's the value when 0 is in the denominator? That's an undefined slope. What kind of lines have undefined slope? Vertical lines. Okay, let's answer the question, are these two lines parallel if we know 2 points on each line? Well, if F contains the point A and B, we'll call A, we'll say this is x1, oops, trying that again, x1 and y1, B we'll call x2 and y2, so I'll say the slope of F, which I'll call like m sub F, that's our y2 minus our y1 over x2 minus x1. That gets us 2 over 4, or a slope of 1/2. Okay. Now if we do the same thing now with line G, and I'll say the slope of line G, m sub G, here's going to be our x1 and our y1. Here's our x2, 2, and y2. Our slope for line G will be 0 minus 1, y2 minus y1, over 4 minus 3, x2 minus x1. That gets us a slope of -1 over 1, which is a slope of -1. So comparing these two answers for slopes, can we conclude that the lines are parallel? And the answer, of course, since the slopes are different, no, they're not parallel, they must intersect. Okay, let's check to see if these lines are perpendicular. Well, we need to figure out their slopes first in order to determine perpendicularity. So let's start with line F. We'll add 2x to both sides of the equation. And we're trying to get the equation in y equals mx plus b form, so I can identify the m. Divide both sides of the equation by 7, and then simplify so we can see the fraction coefficient in front of the x. So the slope for line F is 2/7. Let's do the same thing with line H. We're going to subtract 7x to both sides of the equation. We'll divide both sides by 2, and then again simplifying so that we have a fraction coefficient in front of x, -7/2. So let's compare the slopes. 2/7 and -2/7. These are opposite and reciprocal. One's positive, one's negative. One's 2/7, the other 7/2. So our conclusion, the two lines are in fact perpendicular. Let's try the same thing now with line A and line B. If we start with line A and get 3x plus 5y equals 12 to look like slope-intercept form, we'll subtract 3x from both sides, divide both sides by 5, and then if we rewrite in fraction form, y equals -3/5 x plus 12/5. So this is line A. Let's do the same with line B. We'll take 5x plus 3y equals 18. Subtract 5x. Divide by 3. And y is equal to -5/3 x plus 6. So if we can compare their slopes, this is a slope of -3/5. Careful, this is also a slope of negative, but -5/3. While the numbers are reciprocals, they are not opposite. They're both negative, so our final conclusion, the lines are not perpendicular. Okay, looking at these two lines already in slope-intercept form, y equals 3x minus 4 and y equals 3x plus 4, slopes are the same. So we know these have to be parallel lines. Okay, what if the two equations are y equals 1/2 x minus 4 and y equals 2x plus 7? The 1/2 and the 2 are reciprocals but not opposite. They're both positive, so these are not parallel or perpendicular, but they'll intersect somewhere. Okay, given coordinates of some points, what's the relationship between line PR and ST? Well, if we want to figure out line PR, we need to look at these two points here, P and R. And if we're talking about parallel or perpendicularity, we want their slopes. So line PR, we're going to take the points, coordinates for P, and we'll call them x1 and y1. Whoops, y1. And then point R will be x2 and y2. That up there. So 0 minus 3 divided by -3 minus 0 gets us -3 over -3, or a slope of +1. So that's the slope of PR, so we'll call that M sub PR. Do the same thing now for S and T. So here's my x1, y1, x2, y2, so slope of ST is -2 minus 0 over 0 minus -2. That's a -2 over +2, which is actually a slope of -1. Comparing their slopes here and here, this is a +1, this is a -1, they're opposites. And one is its own reciprocal, so they are also reciprocals. Opposite reciprocal slopes tell us perpendicular lines. How about line R containing these 2 points, line S containing these 2 given points? Check to see if they're perpendicular. So slope of line R, we're going to use x1, y1, x2, y2. The slope of line R, 8 minus 2 over 5 minus negative 2. That's 6 over 7 is our slope for line R. Now let's look at our slope for line S. Here's my x1, y1, x2, y2. So the slope for line S is going to be 0 minus 7 over negative 2 minus negative 8, negative 7 over 6. Negative 7 over 6. Comparing their slopes, they're definitely opposite and reciprocal. These lines are perpendicular. Okay, decide whether the lines are perpendicular. Now we have their equations. Y equals negative 3x plus 4 for line A. The slope there is negative 3. Line B, y equals 1/3 x plus 8. Opposite and reciprocal slopes. Yes, the lines are perpendicular. Last example, write an equation of a line perpendicular to y equals negative 4/5 x plus 2, containing the point 2,5. The perpendicular to a line that has a slope of negative 4/5 means that the slope for our line, our answer, must be the opposite and reciprocal slope. So positive 5/4. I can eliminate choice C. I can eliminate choice D. I can eliminate choice B. And that leaves us with the only possible right answer being choice A.